Hello again, I'm Mr. Cannell. Welcome to the last session in this sequence of lessons about efficient strategies for addition and subtraction. In the previous lesson, Mr. Coombs worked through some examples of balanced equations with an addition expression on one side and a subtraction expression on the other. This was the first practice activity that Mr. Coombs left you with. He asked you to create a balanced equation related to this one, 50,000 plus 25,000 is equal to 150,000 minus 75,000. What did you change? There are lots of possibilities. Let's have a look at one example. And we have to remember that the value of the expressions on each side of an equal symbol must be the same. If you changed one of the addends on the left, how did you keep the equation balanced? Let's say we increased one of the addends by 20,000. What would happen to the difference on the right? Yes, the difference on the right has to be increased by 20,000. Pause the video so you can think of at least two changes you could make to the expression on the right. Welcome back. What did you decide? We could increase the difference by adding 20,000 to the minuend. So that 70,000 plus 25,000 is equal to 170,000 minus 75,000. Or we could decrease the subtrahend by 20,000. So 70,000 as 25,000 is equal to 150,000 minus 55,000. Both ways, both sides of the equation are equal to 95,000. Maybe you increase the difference by increasing the minuend by 10,000 and decreasing the subtrahend by 10,000. As I said, there are lots of different ways that we could approach this, and I'm sure you've got some more ideas of your own. Well done. Here's Mr. Coombs' challenge question. Could you write a story and balanced equation for these representations? Here's my story. Yours will be different, but something to do with length measurements. There are three sisters. Anna is 150 centimetres tall. Faith is 76 centimetres tall. Ellen is 36 centimetres shorter than Anna. How much taller is Ellen than Faith? That's the question. Did you write a balanced equation? What did you do first? The part-part whole model leads us to work out 150 minus 36 here. I've put a blue oval into that part. What does that represent in my story? If there's somebody with you, tell them, or shout out at me. That's it. That's Ellen's height. We can find out Ellen's height by doing 150 minus 36. Here's the balanced equation. 150 minus 36 is equal to 76 plus something. So that something is the red oval. So, can we work out Ellen's height? Yes, 150 minus 36 is 114 centimetres. How can we get the difference then between Ellen's height and Faith's height? What are we going to do now? That's it. We need to do 114 minus 76. What did you get? Whatever your question was, that part of the part whole model is going to be, tell me, that's it, 38 centimetres. Well done. Did the bar model suggest another method to you? What do the blue and red rectangles represent? That's it. The blue rectangle is Ellen's height, and the red rectangle is how much taller Ellen is than Faith. Because remember, Faith is 76 centimetres tall. So we could write a balanced equation. 76 plus something is equal to 150 minus 36. Each side of our balanced equation is equal to each other. What part is 76 plus the question mark and 150 minus 36? What part of the bar model are they both representing? That's it. They're both the blue rectangle. They're both Ellen's height. Maybe you noticed something different. Maybe you did something different for your balanced equation. Look along here. 76 plus the question mark plus 36 is equal to 150. So you might have written your balanced equation like this. 76 plus question mark add 36 is equal to 150. If you add 76 and 36, we've got 112. So our question mark plus 112 is equal to 150. What does that mean the question mark is? 150 minus 112. We know already, don't we? Because we worked it out in the part-whole model. That's it. It's 38 centimetres. Did it matter that we wrote our balanced equation the opposite way around? No, it doesn't matter because both sides of the equation have to be equal to each other. That's the main thing that we need to be able to do. In the rest of this lesson, I'm going to ask you some questions that will help you to think about the strategies you've been learning in this series. Look at these expressions. What symbol should go in the circle? Have a look at those expressions. What's the same and what's different? Remember to look at the numbers in the expressions first to see if there are any connections you could use. Or maybe you could estimate rather than calculate. Pause the video now and come back when you think you know what goes in the circles. Hello again. Have you decided? Let's see if you thought something along these lines. In the top comparison, did you estimate at all? Could you estimate? Could you round off the expression on the right-hand side? The addends on the right. So 2.54 rounds to 3. 3.6 rounds to 4. So the sum of the addends on the right is not going to be any more than 7 because we've rounded up both of those numbers. If we look on the left-hand side, we've already got 7.12 and we're adding on to that. We're already going to be bigger than 7. So that tells us the expression on the left must be bigger than the expression on the right. 7.12 adds 0.78 is greater than 2.54 adds 3.6. What about the bottom comparison? Well, all the numbers are the same, aren't they? But actually on the left-hand side, we've got a subtraction now rather than an addition. If we estimate on the left, we've got 7 subtracts about 1, so that's about 6. And we'd rounded up, hadn't we? 2.54 and 3.6. They're somewhere in between 6 and 7. So we can't really estimate. Don't have any number bonds there, really. We're going to have to calculate, aren't we? We're going to calculate because it's quite close. Let's see what we get. 2.54 at 3.6. Well, we could do that in columns, or maybe we could do that mentally. Just be careful about the 3.6 is 3 wholes and 6 tenths. So think about where you're going to add those tenths in. What did you get? 6.14. If you've got 6.14, well done. Now, yes, we could do 7.12 subtract 0.78 mentally. I'm sure some of you will have mental strategies for that. We'll have a look at the column subtraction as well, because we can do that. So 7.12 subtract 0.78. In the hundredths column, we've got 200 subtract 800. No, we can't do that, can we? So we're going to have to regroup from the tenths column. We'll have to exchange and regroup that 1/10 into 10 hundredths. So we have 12 hundredths subtract 8 hundredths is 4 hundredths. Then in the tenths column, 0 subtract 7. We can't do that either. We're going to have to regroup those 7 wholes. So we'll regroup the 7 wholes, the 7 ones, into 6 ones and 10 tenths. Now we've got 10 tenths subtract 7 tenths is 3 tenths. And then in the ones column, 6 subtract 0 is 6. So 6.34. 6.34 is just a little bit greater than 6.14, isn't it? So we need a greater than symbol in our circle. Is that what you got? Well done if you did. Here are 2 more comparisons. Decide which symbols go in the circles. Remember to look for connections between the expressions that might help you to be more efficient. Pause the video and come back when you're ready. Hello again. What have you found? In the top comparison, did you spot that the minuends in each expression both have a 2 in the ones column, and the subtrahends both have a 4 in the ones column? That should make them quite easy to compare without calculating the actual values of the expressions. From 392 to 482 is an increase of 90, and from 74 to 154 is an increase of only 80. So the difference on the right must be the greater one. Is that what you found? In the bottom comparison, the minuend on the left and the minuend on the right have the same hundreds, tens and ones. Oh, hang on. That's not right, is it? The expression on the left is a subtraction, but the expression on the right is an addition, so we can't use that connection. Okay, we'll have to calculate them. So let's do the addition on the right. 32,216 at 5,588. We'll start in the ones column. 6 ones add 8 ones is 14 ones. That's it. We'll regroup the 14 ones into 110 and 4 ones. I've put my regroup digits below the line. You do whatever you usually do, whatever your teacher has told you to do. Now we're in the tens column. We have 110 add 8 tens add another 110 is 10 tens. 10 tens make, that's it, 100. So we're going to regroup. So we have 100 in the hundreds column and we have 0 in the tens column. Now we're in the hundreds column. So we have 2 hundreds add 5 hundreds plus our other 100 is 8 hundreds. Then we're in the thousands column. 2 thousands add 5 thousands is 7 thousands, and we've got 3 10,000s. So we have a sum of 37,804. Now we'll do the subtraction. 43,216 subtract 5,412. Start in the ones column. 6 ones subtract 2 ones is 4 ones. In the tens column, 1 subtract 1 is 0. Then we're in the hundreds column. We have 200 subtract 400s. We'll need to regroup one of those thousands. So we'll exchange 1,000 into 10 hundredths. So we will have 2 thousands remaining. And we've now got 12 100s. 1200 subtract 400s is 800. Then we have the thousands column. Again, we're going to need to regroup the 10,000s. So we'll exchange 1 10,000 into 10,000s. We have 3 10,000s remaining, and we'll have 12,000. So 12,000 subtract 5,000 is 7,000, and then we have three 10,000s, so 37,804. Wow, those are both equal, so our equal sign will be in the circle. Is that what you found? That would be brilliant if you did that. Well done. I'd like you to do these missing number problems now. Remember to look at the numbers involved at each stage to check whether you could use any of the strategies you've learned, rather than doing a formal calculation. Come back when you're ready with your solutions. Pause the video now. Welcome back. What did you find? Did you use any strategies? In the first question, how did you find the sum on the right? There aren't really any easy connections to spot, so I used column method. The sum on the right is 7,919. To find the missing number, we need the difference between 4,924 and 7,919. Did you notice anything there? Look at the hundreds, tens and ones. They're nearly 3,000 apart. Do you remember using a compensation method with Miss Heaton? We can use this. Let's say it together. I will transform the minuend, then adjust the difference by the same amount. So if I just add 5 to 7,919, I get 7,924, which means I can easily subtract 4,924, giving me a 3,000. I then adjust the difference by 5, so I subtract 5 from 3,000, giving me 2,995. Is that what you found? Did you use that method? That's brilliant if you did. If you didn't, maybe think about it for another question. In the second question, did you notice the sum on the right can be worked out without any regrouping? Did you get £29.97? Hey, that's only 3 pence away from £30. I think we can use that compensation method again. So if we transform the minuend, we can adjust the difference by the same amount. So we want to do £29.97 add £4.90 will give us the missing number. If we add 3 pence to £29.97, we get £30. Then we can add £4.90, giving us £34.90. Then we need to adjust the difference. What do we need to subtract? That's right, we just need to subtract 3 pence from £34.90, giving us £34.87. Is that what you did? Well done if you did. If you got £34.87 by another way, that's great as well. Here's a true or false question for you. The table shows the rainfall measured in a garden for 4 months in millimetres. True or false then? The difference between the amount of rain that fell in July compared to June is the same as the difference between the amount of rain that fell in September compared to August. Can you write calculations to explain your answer? Could you write a balanced equation? Have a go. What did you find? Did you say it's true? Did you write a balanced equation like this one? 87 minus 67 is equal to 48 minus 28. The differences are both 20, aren't they? Which difference shows an increase in the rainfall? That's it. From August to September, the difference increased by 20 millimetres. So which one was a decrease? That's it. June to July, the difference decreased by 20 millimetres. 87 minus 67. Now we're going to see if we can apply any strategies to unknown angle problems. What do you know about the sum of the interior angles in a triangle? If you have someone watching with you, pause the video and discuss it with them. What did he say? That's right, the sum of the 3 angles in any triangle is 180 degrees. What does that square symbol in angle B mean? Well done, that's the symbol for a 90-degree angle, which we call a right angle. That's right. I'd like you to estimate the size of angle C and angle A. Pause the video and have a think, or discuss it with a partner. What did you decide? They're quite close together, aren't they? They're not the same, but they're quite close. Did you decide on this? A is a little bit bigger than angle C. A is 50 degrees and C is 40 degrees. Well done if you were close to those. Watch as I play this video. What stays the same and what changes? That's it. Angle B has stayed the same as 90 degrees. What did A and C do? That's right. As A increased, C decreased. Now focus on the sum of angles A and C. What do you notice now about angle A and angle C? Add those two angles together. What do you notice now about the angles A and angle C? If we add those together, what did you get? That's right. Angle A and angle C always sum in a right-angled triangle to 90 degrees. Watch as the angles change again. Can you work out the size of angle C now? What have you got? 35 degrees? Well done. When we work with angles, it's really useful to be able to know the number bonds to 90. Look at this table. What has stayed the same? Yes, we've kept the angle B of 90 degrees, the right angle. In this balanced equation, do we need to record the 90 degrees? No, we don't, because it's the same in both examples. As A increases, C decreases by the same amount. That's the same sum strategy, isn't it? If one addend is increased by an amount, and the other addend is decreased by the same amount, the sum remains the same. Now you say it on your own. Let's say it together. If one addend is increased by an amount, and the other addend is decreased by the same amount, the sum remains the same. Okay, can you write a balanced equation with these angles? Pause the video and come back when you're ready. We can say that 50 plus 40 degrees is equal to 60 degrees plus angle C. Angle A was increased by 10 degrees, so angle C must be decreased by 10 degrees. So angle C is 30 degrees. Is that what you found? Now I'd like you to write a balanced equation for these two triangles and to work out the size of the unknown angle. Have a good look at the letters on the vertices. Has something changed? Could you use the same sum strategy again? Remember, the value of the expressions on each side of an equals symbol must be the same. Pause the video while you do your writing. Hello again. Did you write something like this? 40 degrees add 50 degrees is equal to 65 degrees add angle C. Angle A has increased by 25 degrees. So angle C needs to be decreased by 25 degrees. So angle C is equal to, you tell me? 25 degrees, that's right. Well done if you got that. Very good. Now look at this balanced equation. What does the letter N represent? Well, N represents an unknown value, but we want to know what that value is, like when we had the empty box problems. I've chosen the letter N. I could choose A, or I could choose B, or T, any letter. I just happen to have chosen the letter N. What do we notice about the numbers in the balanced equation? Yes, the subtrahends have the same hundreds, tens and ones. So can you use a connection between the subtrahends to work out what n represents? Can you remember the generalization that Mr. East shared? Pause now if you think you can work it out. If you'd like a clue, keep watching. Here's Mr. East's generalization. Let's say it together. We can call this the same difference strategy. If we change the minuend and subtrahend by the same amount, the difference stays the same. If you haven't already had a go, see if you can work out n now. How much have the subtrahends changed by? That's right, by 13,000. So the minuends need to have changed by the same amount too. So n, add 13,000, would be 95,400. So to work out n, what did you need to do? That's right, we need to subtract 13,000 from 95,400. Did you do that mentally? I hope so. What did you get? Tell me now. That's it. N is equal to 82,400. Super work if you got that. Well done. Wow, you have completed this set of lessons about calculating flexibly and efficiently. I'd like you to write about what you've learned so you can show your teacher. Maybe you could draw a mind map. You could include the stem sentences and generalizations that you've been saying for adding and subtracting. We've used some of them in this lesson. You could draw some images, like number lines, part-part whole models, or bar models, and write some examples. What advice would you give to other people to help them think about using mental strategies? Thank you for all your hard work and for joining in so well.